Hello and welcome to this video about gravitational potential energy. We can calculate this type of energy using the following equation: EP equals m times g times h, and on your equation sheet you will get given this equation in this format: EP equals m times g times h, and luckily for you they'll tell you what each of the letters means. So EP is the change in gravitational potential energy, m is mass, g is gravitational field strength, and h is a change in height. What you do need to remember, however, are the units. So like all types of energy, gravitational potential energy is measured in joules. Mass, the standard unit for mass is kilograms, so watch out if it's in any other unit. G is gravitational field strength, and that is measured in newtons per kilogram, and h is height in meters. So in every question you need to make sure that those are the standard units. If not, you might have to convert something into the correct units first of all. For example, if you had something in millimeters, you'd have to convert it to meters, or if you had something in kilojoules, you might have to convert it to joules, for example. Now, what is gravitational potential energy? A little bit like potential used in the word elastic potential, it's a kind of stored energy. And when objects are raised, they gain gravitational potential energy. So if I was to put this pen on the desk right now, as soon as I move it up, it's gaining gravitational potential energy. And then if I were to drop this pen, that would be immediately transformed into kinetic energy until it reaches the bottom. Okay, so any movement of an object vertically upwards, it's gaining gravitational potential energy, and then as soon as it's dropped, it's starting to be transformed into kinetic energy until right just at the bottom you've got a maximum kinetic energy. And we discussed the link between gravitational potential energy and kinetic energy in a previous video, and we'll highlight on it as well here as it's important when we talk about gravitational potential energy as well. So this kind of stored energy, in fact we say when an object is raised vertically, we say work is done against gravitational forces and the object gains gravitational potential energy. So we'll link this into work done when we do a video about work done. But work is done against gravitational forces, or against gravity, when an object is raised and it gains gravitational potential energy. Okay, so let's look at a couple of examples where you might get questions about gravitational potential energy. Let's start over here, and you might have a person on top of the ladder, and you might be asked to calculate the gravitational potential energy of that person whilst they're up the ladder. And for that you'd need to know the person's mass, you need to know the gravitational field strength, and you need to know the height. So the gravitational field strength you need to look out for in the question and highlight it as soon as it comes up, because it will be given to you. Gravitational field strength on Earth is 10 newtons per kilogram, and they'll give that to you somewhere in the question. They'll also, if they're asking you to work out gravitational potential energy, give you the mass of the person. So if we assume now, if G is 10 newtons per kilogram, let's assume the mass of this person is 70 kilograms. And then we need to look at height. Now, importantly, it's not this diagonal height here. We take the height vertically. So you must be measuring the height as a vertical height upwards, okay, as opposed to on any slope or slants like that. This is the measurement height that we're looking at. And if we assume that he's working at a height of 2 meters, we can calculate the gravitational potential energy, because we've got mass as 70 times by the gravitational field strength on Earth, which is 10, multiplied the height that he's working at, and we know that that person at the top of the ladder is storing a gravitational potential energy of 1400 joules. Okay, linking into kinetic energy, if that person were to fall off the ladder just before he hit the ground, all of that gravitational potential energy would have been transformed into kinetic energy, which would have that same value of 1400 joules. If we look at it in terms of a waterfall, so if you had an object at the top of the waterfall, that would be storing gravitational potential energy. You'd need to know the mass of the object, you need the gravitational field strength of 10, and you need to know the height of the waterfall. And you could then calculate the gravitational potential energy stored in that object. Again, this is where it links into kinetic energy, and you need to remember this idea of the fact that when an object falls, the gravitational potential energy is converted into kinetic energy. That's really important to remember throughout your exam, that the gravitational potential energy is transformed into kinetic energy as the object falls. Okay, so if something, an object at the top of the waterfall had gravitational potential energy of 2000 joules, for example, that would all be transformed into kinetic energy. So just before it hit the water, it would have a kinetic energy of 2000 joules. If it had 10,000 joules of potential energy up here, it would all be transformed into 10,000 joules of kinetic energy, and so on and so on. So all of that energy is transformed. So here's a question for you to have a go at. If you pause the video, work it out for yourselves, and then come back and see if you got the answer right. So the question says, at point X on the roller coaster, which is here, is 20 meters high. If the mass of the roller coaster carriage is 5,000 kilograms, calculate the gravitational potential energy of the roller coaster. So we've got EP as our equation equals m times g times h. So gravitational potential energy equals 5,000 times by g. And then I think to myself, they haven't given me g in this direct question. Have they written it somewhere else which is visible to me? Yes, they have. It's over here. So do look for this, because they won't necessarily write it in the same spiel. They might have it just above a diagram or something for you to search for. That's why I put it over here on purpose. So 5,000 times 10, because that's the g bit, and that's the mass, times by the height, which is 20 meters. And if we use our calculator, we can calculate that the gravitational potential energy of the roller coaster is 5,000 times by 10 times by 20 meters, which is 1,000,000 joules. Okay, second question here, it says calculate the kinetic energy of the roller coaster at point Y. Now, I've said this in the previous video, but what you need to look out for is the fact that this is only one mark. If you see questions with only one mark, that should be alarm bells ringing, to think they don't want me to use an equation and show loads of working out. It's probably that I've written the answer down in the previous question and I just need to copy that answer down. And this is exactly the case here, because it says calculate the kinetic energy of the roller coaster at point Y, which is here. And if you remember that all the gravitational potential energy is transformed into kinetic energy, then at point Y the roller coaster will have a kinetic energy which is equal to the answer that we've calculated here. So at point Y the kinetic energy is 1,000,000 joules. Okay, so very well done if you got those answers correct. Don't forget to put the units on your answers, and don't forget to look out for those 1-mark questions. If you found the video useful, then please press the like button and feel free to subscribe. Thanks for watching.